In this recording, we're going to review for you how to solve systems of linear equations. So you probably learned from a previous math class, maybe you forgot, but a system of equations has two or more equations, and in this case we're using x and y as our unknowns, and they have the same set of unknowns. So we wouldn't be able to solve this bottom of equation here, this one that says 2x plus y equals 3, because there's multiple values of x and y that make that true, right? I mean, you could think of some. I'll just come up with 0 for x and 3 for y. That would solve it. How about 1 for x and 1 for y? There's another solution, right? You could think of 2 for x, negative 1 for y. All right, so you can see there's lots of possibilities for that bottom equation, but there's only one point that would potentially solve both equations, because you can think a line would only cross another line possibly one place. Okay. The other possibility is that there are no solutions, or where these don't cross at all. And finally, you might have a situation where they are the same line, so they're basically on top of each other. Okay. Now there's several ways you can solve a system of equations. I don't want you to feel that there's only one. You could certainly solve by substitution, getting one of the variables by itself and then substituting. You could solve by guess and check, which is always an option, but not a very efficient one. The method I'd like to lead you to in this case is elimination. Okay, so we're going to try to eliminate one of the variables from the system by adding. All right, so you've done this before, but just to review, why are we allowed to do this? Well, you're always allowed to add something that is equal to both sides, right? I could add 3 to the right side as long as I add 3 to the left side. Okay, so I am going to add 3 to the right side, but instead of adding a 3 to the left side, I'm going to add something that's equivalent to 3. Now this 2x plus y doesn't look like a 3, but because of the equal sign, we know it is equal. Right? So I can add these equations, and when I do so, those y's add to 0, and we just end up with 5x equals 5. That's easy to solve. We know now x is 1, so that's half the battle. And now we're going to solve to find out what y is. So pick either of these equations, whichever one looks easier to you. I'll use the bottom one. And just sub in 2 times 1 plus whatever y is has equaled 3. Well, that's going to be easy also, right? 2 plus what equals 3? Well, the only possibility would be 1. Okay, so we have our solution. Because it's x and y, I can write it in parentheses like this as a coordinate pair. If it were other letters used as the variables, like m's and n's or something, you're not going to want to use that because it might be a little ambiguous. We don't really have a convention for you put the first letter that's earlier in the alphabet first. Just write it out, like m equals 1, n equals 1, something like that. Finally, the directions say check your result. Go ahead and check your result and play the recording when you have checked by subbing in to both equations the value x equals 1 and y equals 1. Okay, hopefully you paused and are only playing the recording now that you've checked your result. Here are the check. Okay, this is how I do the check. You just substitute in the numbers for x and y, their values, and then show that both sides are equal. This evaluation of one side could be done on a calculator if necessary. It could be done in your head. At this level of math, I don't need to see the work shown. Just show what you subbed in and then show that both sides are equal. I do caution you though, don't simply just write it down that 2 equals 2. Really make sure the left side is 2. Otherwise, if it's not, you'll have caught the mistake and hopefully go back and fix it. All right, so let's tackle question number 2 here. This one's a little more complicated because you've got neither variable, neither x nor y, has opposite coefficients. You got to do a little manipulation of these, as we call this linear combinations or multiplication. You want to get the same, or actually in fact opposites. It would be better if these were like 3 and negative 3, right? So I can think of a way to turn the 3 and the 2 into the same value, or I can think of the way to make a negative 12 and a 4 into the same value, or in fact opposites. If I want to make the 3 and the 2 the same, I'd have to multiply the 3 by a number that would turn it into something that 2 also goes into. In other words, like 6, right? A common multiple. So I can multiply the top by negative 2 and the bottom by 3, and that would work. I'm going to stick with the y's here. So I'm going to leave the top one as negative 12. I'm going to multiply the bottom one by a 3. That will guarantee me that the y's have negative 12 and positive 12. All right, so I'll go about it that way. Then just rewrite we've got 3x minus 12y equals negative 12. All right, and work out. So now I've got 6x plus 12y. If this is easy for you, what I want you to do is just work out this problem and then play the recording to show the check. If this is still something that you're like, I'm going to need to see this one worked out, go ahead and keep watching. Okay, you work this problem out with me. So now I've got the y's to be opposite signs. So I'm going to add this expression to the left side and this expression to the right side. And because they're equal, I'm allowed to do that. I'm allowed to add them to both sides. So the 12s add to 0, right? Some people would say they cancel. You're not going to hear me say that. You're going to hear add to 0. So now I've got 9x equals 36. Oh, that's easy, right? Nice multiple there. X equals 4. Pick whichever equation you think would be easier. I'm going with the bottom one. I'm just going to make that substitution. 2 times 4 plus 4 times we don't know yet equals 16. Go ahead and work that out. So 4y is 8, and obviously y is 2. Because we're still dealing with x and y in our variable, I can write it as 4 comma 2. Pause and play the recording when you've checked. Okay, so hopefully you did your check here. Just like I explained before, that's enough work. If you want to show more, you may. In example 3, we really ratcheted up a little bit. We've got fractions involved, and I know from experience a lot of students get uncomfortable when fractions are involved. So my suggestion has always been, if you have an equation that has fractions and you don't like that, well, let's multiply all the terms by some factor so that we eliminate the fractions, right? Let's get rid of what we don't like. So I have to think of a lowest common multiple, a number that 2 and 3 both go into that will divide out the 2 and 3. So of course I'm thinking about 6, right? So I'm going to multiply, and in this case, I'm not sure why we're getting Technicolor there, but we are. I'm going to multiply each term by its own separate 6. Okay, and I'll show you why. It's because of this. This 6 is going to divide out this 2 and leave a 3 as a factor. This 3 and this 6 are going to divide out and leave a 2 as a factor. So what that's going to result in is I've got 3 times 3, I've got 9x. I've got negative 2y times 2, I've got negative 4x. Sorry, negative 4y. And then I've got 60. Okay. So now I'm going to kind of jump ahead here and try to make my life easier. I need a way to make half into a 9 or half into a 4. And I think it's going to be a lot easier with the 4, right? I mean, 9 would be a little bigger. So I'm going to multiply all the terms by an 8 so that I not only divide out the 2, but I get a 4y as a result. Okay, so I'm going to multiply by 8, those divide out, and I end up with a 4. To multiply here by 8, these divide out, and I end up with a 4. Multiply by 8. So you're going to multiply everything by 8, and the result is 4x plus 4y equals negative 8. And now it starts to look a lot like the ones we've been doing. See if you can take it from there, finish it off, and then play the recording. Okay, so at this point, these add to 0. 13x is 52. X is 4. Now we can easily figure out the y. You're going to go back to either one of these original equations, kind of like the bottom one. And I'm going to go with 4 halves plus y over 2 equals negative 1. And at this point, I've got 2 plus y over 2 equals negative 1. When you deal with this, y over 2 equals negative 3, you're going to multiply both sides by 2 to divide out that 2. And I've got y equals negative 6. Okay, we're going to do our check. Play the recording when you've checked. All right, and here's your check. They do both check out. All right, so for this final example, I want you to work this one out on your own. Play the recording when you've gotten as far as you can, and then I will show you the solution. Okay, so hopefully you work this one out the best you can. You can figure out a way to get these to be the opposite signs, either the A's or the C's. And here's my solution to this problem. Okay, I multiplied the top equation by 3 to get the C's on the top to be 6, bottom equation by -2 to get the C's in the second equation to be -6. From here, it's just like all the other ones we've done. They add to 0, A is -1, sub in your A value here, work out for C. I'm going to express it this way because we don't have a clear which one's first in an ordered pair. All right? And finally, your check. They do indeed check out. Thanks for watching.